Hello, everyone, and welcome to this session. My name is Jesse Anderson, and my company is called Big Data Institute. In this session, we're going to be talking about managing real-time data teams. And this is a crucial thing for companies to think about. My background is pretty significant on this. I've managed real-time data teams. I have mentored companies all over the world about how they needed to make sure that their teams were ready and make sure that their teams were ready to actually work with big data in real time. And in this session, I'm going to share with you some of the realizations and some of the issues that I've seen so that you can avoid them. What I really want you to come out with this session as saying, here is what we've wanted to show. So I've just brought up a poll. I'd like to know generally who you are so that I can make sure that I'm talking to the right audience. And I see that some people are feeling that already. So very good. So with that, let's talk about our itinerary. Our itinerary for this session is we're going to talk about the effect. There are specific effects on data teams, and we need to understand them. And those effects will manifest, in my opinion, in two main ways. One way is operationally, that the operations team are they ready? Are they actually doing this right? And from there, that manifests as the data engineering side. What do we do? What do the data engineers do? And from there, we'll talk about what are some specific things that we should be doing as teams. So let's continue on and start talking about the real-time effect. So one of the really important things to know is that choosing a real-time technology is more than just a technology choice. Sometimes companies or organizations start thinking, okay, if we go from a batch technology, maybe it's small data, maybe it's big data, maybe we're going from Apache Hadoop, maybe Apache Spark doing batch, and we just say, okay, we're going to start doing Flink now. And that choice of moving to Flink is now, hey, we're just going to up and operationalize this and everybody's happy. I really want managers to understand this as this is more than just a simple technology choice. We just don't up and choose Kafka and Flink, for example. We have to deal with this. And this is because data teams are affected by this move to real time. These data teams are going to have to deal with some of the ramifications. And one of the biggest ramifications here is the complexity increase. The complexity increase of going from, let's say, small data to real-time big data with Flink is dramatic. The increase in complexity, and this is sometimes where companies who are doing something with, let's say, Hadoop or with Spark, or companies are doing something in batch with real-time with Hadoop or Spark, and then they move and they think that moving to real-time is a lateral move. That isn't the case. And I've seen this many times. It is really important that the team, the organization, the managers, more importantly, understand that this is more than just a technology move. It is not a lateral move. It's a decent step up in complexity. That makes the team have to think about something. And this is a crucial thought for you. As I look over the people who are attending, we have some CXOs, we have some managers, lead developers. What I would really encourage you to do is to think about, is the team ready initially? Because the teams may actually need some pretty extensive preparation before starting that real-time project. They need to actually think about what needs to be done. Perhaps it's training, perhaps it's consulting, perhaps it's XYZ, but there may actually be some specific things that need to happen before we actually start that real-time project. Otherwise, teams can stagnate. Where we may have made some progress with a batch technology, if the team was just barely able to just getting by with batch, they could hit the stagnation. And this stagnation can be a major issue for teams, for especially data teams, as they try to go through and work with this. So now let's talk about some of the specific manifestations. And we're going to start off with the operations issues. And in my opinion, this is one of the bigger issues that I think hits, and I think it's one of the more unknown unknowns. If you're familiar with that term, it means that management doesn't know that or realize that there's an operational onus and a higher level that goes on that for the operations team. So what happens when we're missing one of the data teams? So here you see this visualization. And in this visualization, there's the three data teams. There's data science, data engineering, and operations. But let's imagine that we either don't have our operations team, or that we're completely missing, or that the operations team is not up to snuff, as it were, to do real-time operations. So this means that we don't have a real-time excellence. We don't have a real-time operational excellence. What does this lack of real-time excellence mean? Let's take a look at that. And one of those is real-time SLAs. So their SLA stands for service level agreement. Well, when we go from batch to real-time, there's a significant difference between one and the other. Where when we have an operations team that is barely keeping up with a batch SLA, usually batch SLAs are in terms of hours and days. And when something goes down, when something is broken, code is broken, for example, there is an SLA that the operations team maintains that's in hours or days. At some of the companies I've actually consulted at, this can be 5 business days. And that's a pretty wide range. That's a pretty significant amount of time. And the reason that a team can actually do that, an operations team can handle this SLA, is because the operational, the real-time necessity for it, the actual ability to deal with downtime is significantly higher for batch SLAs. And when an operations team is used to this very cushy days sort of level, then once we get into these real-time SLAs, those real-time SLAs are much more stringent. We're talking about minutes to hours. And the thing that managers should ask themselves and ask the team is the operations team ready to handle a more stringent real-time SLA? And in this time frame, this could be minutes to hours. And this sort of SLA can manifest several different ways. Are they ready to operate a Flink cluster, for example? Are they ready to operate the Kafka cluster? Do they have the extra resources to be able to, let's say if you're on-prem and you have a total hardware failure, do you have the hardware on hand to deal with that? There's a lot of different questions and a lot of different manifestations that come into this real-time SLA. One of the ways that I help teams and especially management think about, do they need real-time processing, is I ask them operationally, what is the manifestation if you actually go down? And put a different way is, if you were to go down right now and not be able to do real-time processing, what would be the effect on the business? Would the effect on the business be, oh, well, we have a day, we can wait a day for this, for these operational manifestations for that data, for that analytic, for example? Or does the business say being down for a minute would kill us? It would be, we would live through it, but it would just be absolute pulling teeth, very difficult for us. Management needs to understand this, because a real-time SLA should have a manifestation, a clear manifestation for the data teams, for the operations teams, so that they can actually go through and work with the data at that scale and at those real-time SLA numbers. Then we have business SLAs. One of the manifestations that is often a very unknown, as it were, is what is the effect on the business if we can't maintain an SLA, our service level agreement? What happens is that ineffective operations teams who can't or don't keep their SLAs has the manifestation that the business can't actually rely on them. And if you talk to those business folks about what is happening or what they're trying to do, what will happen is they'll actually say, oh yeah, we couldn't rely on it. It always kept on going down. That's usually the words that they say. It's always down. I can't rely on it. And so what will happen is, even if the data engineering team, even if the data scientists, top-notch, doing great work, if we can't maintain an operational SLA, the manifestation here will be that the business can't even rely on it. So you as management need to really identify and say, are we able to maintain that SLA? If we don't, the business will say, All right, I can't use it. And they'll go elsewhere. They'll use something else. They'll make do with something else. Our next manifestation is on the actual data engineering issues. So here in our, looking back at the diagram once more, we have our three data teams: data engineering, data science, and operations. But let's imagine that we did have data science and we did have operations, but we're missing data engineering. And this happens more often than we'd like to admit. I think it happens pretty often where either the data engineering team is either unskilled or is completely missing, where we have data engineers being DBAs, data warehouse people. Those aren't the type of people that will be able to handle this real-time thing. That is one of the things I'd like you to take out of this session, is that data engineers have to be software engineers, have to have been software engineers, have to know how to program. This is not a new level or a different name for data warehousing, for DBAs, for doing SQL things. So what happens is, if we're missing our data engineering component, what this will manifest as is wrong architectures, wrong tool for the job, where when you're in management, what you'll hear from the data engineers who either are missing, or perhaps the data scientists that are filling in for those data engineers, they're choosing things by guesses. They're choosing architectures by looking around and saying, what's cool, what's hot, what have I heard about? And you can't do that in data engineering. You can't do that with software engineering, because if you just choose the wrong tool for the job, you could be maybe okay. But if you're choosing the wrong tool for the job, you could either really constrain yourself, or you could do something that isn't possible. You could be trying to use a technology for something that it can't even be used for. And these aren't hypotheticals. This is exactly what I've seen out of data scientists trying to do data engineering architecture and trying to do data engineering design or code. I've written pretty extensively about this. I would highly suggest, as managers, to make sure that you have your data engineering team in place and with the right skills. And to this end, some data teams or data engineering teams they're doing okay at batch. And what they're able to do is they're able to kind of get by with batch. And in those cases, and I've seen this, worked with those teams, but they can barely get by with that batch. Creating real-time systems is going to be impossible. And this is one of the management sort of issues that needs to be out there for you. For you as managers, you need to realize, hey, the team will actually need to be changed. The data engineering team, if they can barely do that batch, maybe they're doing that batch and getting by with batch because they could do everything with SQL. I've seen that pretty often, where the data engineering team is actually made up of a bunch of DBAs. And these bunch of DBAs were able to get by with batch things because they could create these SQL scripts. But once it came down to the real time, down to the more complex batch use cases, those sorts of things weren't possible. Management needs to understand this and needs to know this, that your data engineering team may need to not just upskill. In other words, they may not just need to learn Kafka, Flink, whatever. You may actually need to be augmenting the team with new people, with new leads, new lead developers. You may need to get some outside help. And that outside help could be, as I just mentioned, hiring new people with those skills, people that have those skills. But I would also say, if your real-time sort of use case is really difficult, you may need consulting help. You may need somebody to come in and say, here is your architecture, here is what you need to do. As we start to deal with this batch and real-time manifestation, you may need to make actual structural changes to the team of adding new people. The next are our data products. One of the biggest differences, I think, for management, perhaps product management, and I would also say for the rest of the organization, is what does a real-time data product look like? And that real-time data product actually changes how we expose things. And for organizations that I've dealt with, where they're used to exposing data as either an RPC, a remote procedure call, or an API or a REST call, coming and saying, I'm going to offer real-time data products is quite a mind change. And management needs to understand this. Management needs to address this. So what we can't do is with our real-time data products, you couldn't just say, okay, I'll expose a REST API and they'll get everything. Can't do that. If you're doing true big data problems, hey, you won't be able to get 5,000, 10,000, a million events per second through a REST API call. That's why we had to create these systems, and we couldn't do this over an API. So what we do is we as managers need to start thinking about how do we expose those data products the right way. Now, there's obviously some technical parts to this, but there's also some other parts to this that are management of how does the manager actually go and talk about this within the organization? How do we make sure that we have good adoption, that other people within the organization are actually using our data products? And to that end, we have to make sure that our data products have a schema. Now, their schema can be a somewhat contentious thing, but at a minimum, there should be some kind of schema, whether it's JSON, maybe it's XML. Those are two ones that I would disagree with using, but if you absolutely have to do it, they're better than nothing. Personally, I would strongly advise you to use a binary schema like Avro or perhaps Protobuf, because when we change data from in real time, we can't just go back and say, hey, we've made this or that change. What we've ideally done is we've used a binary schema that can handle that schema evolution. That's what we really want to do. Another one that I find with more highly politicized organizations is when we expose data products, especially real-time data products, it's harder to know who is using it. There isn't a specific knowledge of or a specific business technical process that says, hey, somebody is using my real-time data product. And sometimes at a big company, there may be a real-time data product that's out there, and they may not know everyone who's using it. And some of my customers have actually put business processes in place to know who is using that data product so that there can be some knowledge of that. But in any case, we're having to remove silos in a different way. These real-time data products cannot be held in like this, where we're kind of trying to keep it all in, not let anybody else use it. What we're trying to do is we're trying to make real-time data products that are usable throughout the organization. When you're creating that initial real-time data product, you may be thinking of this, this, and this, but once the rest of the organization hears about it or knows about it, they may have this other idea. Oh, you actually filled in one of the pieces that I need. Let me get that. Let me bring that in so that I can process that. Here's this new analytic. This is what I've seen. This isn't a hypothetical. This is what actually happens when real-time data products get out there, is that the rest of the organization will start to adopt it and realize, oh, there was some level of value that we could do there. The next thing is our connections, especially on the data engineering side. I talk about high bandwidth connections here. High bandwidth connections means how well connected would you say that your data engineering team is with the rest of the organization, or let's say with the data scientists? It's incredibly important that the data engineering team have high bandwidth connections, especially to the data science team, because otherwise the data science team will take that real-time data product and either misuse it, or they'll take something, the infrastructure, for example, or the architecture, and completely abuse it. So we need that high bandwidth connection between those two teams. Otherwise, we're going to have a bunch of technical debt created by, for example, the data scientists, or for example, the rest of the organization. That the rest of the organization may, let's say they don't have that background in distributed systems. They don't have that background in big data. So they take that real-time data feed and abuse it in some way that is detrimental or creates a mountain of technical debt. What we really have to do as management is make sure that the data engineering team is not the police, but they're there in my opinion, initially a consultative way. What that means, that consultative way, is that means that they're kind of consulting with the rest of the organization to make sure that the rest of the organization is doing the right things with the tools, that they're not taking Flink and using Flink in some crazy way that will take a data engineer weeks, months, years to figure it out and to fix it. This is really what we don't want. The next thing we really need to do as management is to make sure we have the right ratios. So what I want you to think about as managers is, what is the ratio now? Let's say you're doing doing batch processing. How does that ratio change, or what does the complexity change happen when we go to real time? And this is really an important question as you start to look at sizing the team and making promises to your higher ups that says we are going to get X done. Because if we are going from the wrong ratio, if we are coming at it from a ratio of, let's say, what our data scientists to data engineers is, what we can do is we may have to lean on our data scientists to create something in real time. We may have to wait for them to create a piece of code that is or let's say an analytic or something like that is being done in real time, that was written entirely by the data scientists, instead of having the data engineers really work with them on that, make sure that the code quality is up to date, that the code quality manifestations are correct. This is really important because otherwise management will have to deal with this technical debt. I have one client, we're dealing with this right now. They have the wrong ratios. They're trying to make this bridge. They're trying to bridge this gap between real time and from doing batch now they're wanting to do real time. They don't have the right ratios of data scientists to data engineers right now. They don't have enough data engineers, quite frankly. And so now what we have to do is we have to deal with that. We're part of the reason we don't have enough data engineers was because of that technical debt that was there initially from the data scientists. So as we're moving from batch to real time, we're having to do that and pay down the data scientist technical debt. Fighting these wars on several different fronts is really difficult for teams, especially data engineering teams, and even more so when they don't have enough data engineers. So what I really encourage management to think about is, what is that step up in complexity for the data engineers? And this just isn't the step up in complexity, let's say between a Spark batch and Flink doing it in real time is pretty well known. What isn't well known and what is very specific to your company is actually what levels it is for your company, for your use case. Are you doing sort of hello world style, pretty simple down the line analytics, for example, or are you trying to do something that's pretty complex? That sort of difference is really what's going to give you the main difference, what that right ratio is. So let's talk about, I've shared some specific items and what to do about them, but let's go even deeper on what to do. What I'd strongly advise you all to do is to think about where in COVID, so COVID is worldwide. No matter where you are, we're all experiencing something from COVID. What I would really strongly advise management to think about is, why are we moving from, let's say, batch to real time? Is there a specific business value that we are getting? Could you come back and when, let's say the CTO says, hey, management, you've given me a bill for $1 million, €1 million. And you've told me it's going to take a budget of €1 million or $1 million. What we need to be able to point back to and say, yes, because of the business wanting X and the value that the X will create, we think that investment of $1 million will result in $10 million of extra sales, of extra revenue. So what I really encourage management to think about is, not to be a team that's looking for problems to solve. What you should be doing is solving business problems, real business problems with quantifiable ROI in real time. That's really what we need to be doing. And this is one of my biggest recommendations to you as a group and as management, is to think about, how do we do this? How do we do this right? What are the problems that we can solve in real time that will have a significant business value, significant business ROI? One other thing that I've been doing personally, and I'll recommend to you, is you may be thinking, okay, well, with COVID, our business ROI is down. We can't specifically say we're going to do X. Well, there's two ways you can deal with that. Maybe what you're not trying to do is to create more revenue. Maybe what you're trying to do is to cut costs, cut churn, that sort of thing, and do that in real time. That is an example. Or what I've been doing personally is I've been thinking about this as what we're doing now is an investment that it's going to pay off 6 months from now, a year from now. As you're looking at doing, let's say, a Flink project or something like that, this is exactly what you may be doing. It may take you a year to get there. And by that time, ideally, our worldwide economy is back doing better. And these are the sorts of investments that are good now. They will pay off. So what we need to do is we need to, management also needs to communicate their value. One common issue for management is that, and especially as we get into real time, is that you'll always be compared to the less technical fields or to other technical fields. You will always get a pushback from, let's say, the CTO that says, oh, why do you need 10 million euros for this project? The web team just asked for 100,000 and they're able to do X, Y, Z. Or you're telling me it's going to take a year to create this real-time project. The web team just came to me and said they just need a month to do this. This is an issue that management will have to deal with. Management needs to communicate a few things about real-time data teams and real-time big data, is that there's going to be a significant increase in complexity. And it's not up to, let's say, your architects, your developers to present this. In my opinion, it's up to the management to communicate this and make sure that their manager and their manager's manager, ideally as much up the chain as possible, so that they know, hey, this is way more complex than setting up a website, for example, or writing some web code. We may be powering something on the web, but this is far, far more complex. And as a direct result, it is more expensive and it takes more specialized people and it's going to be costlier. And this is oftentimes something I find that is a surprise to upper level management, quite honestly, that no one ever told them. It was the CXO level. No one ever told them, hey, this is going to be more complex. This is going to be, whereas we're here in complexity for our web stuff, we're going to be up here for our real-time data teams, and it's going to be more costly. By telling people up front about what it is and what's going to happen, there will be less pushback. So that's really what you want to do. You want to communicate that value. Otherwise, if we don't communicate that value, especially in this COVID era, one of the issues could be the team, the CTO, as they're doing layoffs, they'll say, okay, we can cut the entire team. We can make significant cuts. Whereas in my opinion and experience, there is a significantly higher amount of tribal knowledge in data teams than there are in other teams. So management will want to know that. And you may need to communicate that. So one of the things I really want you to take away from this session is that although we're at a Flink conference, obviously, and we're thinking about Flink, Flink is a technology that enables something on the business side. So it's really up to the management and it's really the management's responsibility for that early success or failure. Because how you've set up the team for either failure or success is up to management. It is entirely a management issue. Flink works really well. Flink works well for this, but if we never get to that point where we've actually deployed onto Flink, that is a management issue and management didn't put the right team in place, didn't give the team the resources, for example. So really, if you're thinking about this and you're thinking, oh man, our team we need to be going this way and the team is off on this other tangent, completely off on it, guess what? It's management's responsibility for getting that team back on track. And to help organizations do this, especially management, I've written my third book. It's called Data Teams. There's the URL right there, and you can sign up and be notified when that book is released, hopefully soon. But the Data Teams, what I tried to do with Data Teams is explain a few things. One is the need for all three teams: data science, data engineering, and operations. But I think what's different about this book is I brought in, and here is the business side of this. Here's what management needs to do to engage the business side. In the book, I talk about everything from how do you get the team back on track to case studies of, in some cases, they were companies doing real time at scale. So I'd encourage you to check out that book once it's released. So with that, I am going to thank you for coming and open it up to questions.